Hey everyone, and welcome to day one of onboarding. I am literally so pumped to have you all here. Today is all about getting you totally up to speed with how we build apps on this team. We're going to completely demystify the Flutter widget tree and dig deep into the MVVM architecture. You know, if you've ever looked at a massive file of Flutter code and just felt completely overwhelmed by all the nested brackets, don't worry, by the end of this onboarding explainer, you're going to see that code in a completely different way. So, here's a quick look at our itinerary for this session. 1. The Flutter UI mindset. 2. Separating view and logic. 3. Deconstructing the login screen. 4. Handling user interactions. 5. Navigation and home screen. And 6. The 3 rules of state. It's a packed agenda, but it's going to give you exactly the front-end architecture breakdown you need.
All right, let's kick things off with section 1, the Flutter UI mindset.
Okay, let's dive into this. This is really all about adopting that senior developer perspective. We don't just stare at a wall of nested spaghetti code, we read the widget tree structurally. When you look at a Flutter screen, I want you to visualize 6 distinct structural layers. First, you have the frame, which is usually your scaffold. Second, the safe area, so your app doesn't awkwardly hide behind a phone's notch. Third is alignment and scroll, how things are centered and whether they can move. Fourth is size, which restricts how big elements can actually get. Fifth, decoration, like cards and padding. And finally, the 6th layer, content and interaction. The outer layers define the layout, while the inner layers handle what the user actually sees and clicks. You basically read it like an onion, peeling it from the outside in.
Moving right along to section 2, separating view and logic with the MVVM architecture.
Before we write a single line of UI code, we absolutely have to establish strict boundaries for our architecture. Notice how cleanly responsibilities are divided in the MVVM pattern. Model, view, ViewModel. On one side, we have the view. Think of your login page or home page. Its only job is to display the UI and forward user actions. On the other side, we have the ViewModel, like our login view model. This is the brain of the operation. It manages the state, talks to the database, and calls the APIs. Our view widgets should never, ever handle raw business logic.
I literally want to stamp this quote into your memory right now. View only displays data and forwards actions. Logic should not be in the widget. This is the golden rule of MVVM. Your UI is essentially just a dumb reflection of the view model state. It doesn't think, it just shows. When a user clicks login, the view doesn't authenticate them. It just taps the view model on the shoulder and says, hey, the user wants to log in with these credentials. You handle it.
So, what exactly is the view getting from the view model then? Well, it's reading very specific data points and actions to render correctly. It needs to know, is loading true? Should I show a spinning loading wheel? Is there an error message? Did something go wrong that I need to display in red text? Who is the current user right now? And of course, it needs access to executable actions, specifically the login and logout functions. The view just listens to these, and whenever the view model updates them, the UI automatically redraws to match. That brings us to section 3, deconstructing the login screen.
Let's shift our focus to our first practical task and apply that blueprint to the front door of our app. We're going to build the outer shell of our login screen before we even think about text fields. Our foundation relies on 3 key widgets. The scaffold provides the standard material design framework. It gives us our blank canvas. Inside that, we wrap everything in a safe area, which ensures our UI doesn't overlap with the device's status bar or home indicator. And then, we wrap it all in a single scroll child scroller.
Now, you might be wondering, what happens on a small phone screen if we forget to include that single child scroll view and the user taps the text field to bring up the virtual keyboard? Well, boom, you get the dreaded yellow and black striped tape of a RenderFlex overflow error. The keyboard pushes up, literally crushing your widgets because they have nowhere to go. Single child scroll view absolutely saves the day by allowing the content to neatly slide up and out of the way.
Section 4. Handling user interactions.
All right, now that our layout is safe and structured, let's move deeper into the widget tree to where the user actually interacts. The absolutely crucial point here is understanding the difference between shared state and local state. Think about the little eyeball icon that toggles password visibility. Turning the password text into dots is just a simple UI interaction. It doesn't fetch data, it doesn't affect any other screen. For this, we use a local set state right inside the widget. Keep it out of the view model. We don't want to bother our heavy-lifting view model with a trivial visual toggle. When the user actually hits that login button, we kick off an asynchronous flow. Step 1, the view reads the view model. Step 2, it calls the login function and we await the processing. Step 3 is critical. Because this is async, the user might have actually closed the app or backed out while it was loading. So we check if the widget is mounted. If the widget isn't on screen anymore, we stop right there to avoid a crash. Step 4, if the widget is still mounted and the login was a success, only then do we navigate to the next screen.
Section 5. Navigation and the home screen. Boom! We're in. We've successfully logged in, and now we're entering the house, which is our homepage. And this brilliantly illustrates how we handle dynamic UI rendering on the home screen. We rely on the current user state from the view model, and we use a simple ternary operator in our build method. If the current user is null, maybe the data hasn't loaded yet or their session expired, we safely show a fallback text widget. If it is not null, we render the full profile card. It's clean, it's safe, and it completely prevents no reference crashes.
Navigation isn't just about moving forward, though. It's about managing history. Look at these two methods. When we log in, we use push replacement named. This swaps the login page for the home page. So if the user hits the back button on Android, they exit the app entirely instead of awkwardly returning to the login form. But for logout, we use push named and remove until. This is basically the nuclear option. It wipes the entire route stack clean and drops the user back at the login screen. We do this to ensure absolutely no authenticated screens are left lingering in the app's history.
And finally, Section 6, the 3 rules of state. To wrap up the technical deep dive here, consider this your ultimate senior dev cheat sheet for state management. You essentially have 3 tools. Tool number 1, context.read. Use this when you want to call an action, but you don't care about UI changes, like triggering a login or logout. It does not rebuild the widget. Tool number 2, context.watch. Use this when your UI needs to react to changes, like watching is loading or current user. It will rebuild your widget when those values change. And tool number 3, set state. Use this exclusively for local, ephemeral UI state, like toggling that password visibility. Keep these rules handy, and you'll always know exactly which tool to pull from your belt.
Okay, let's do a super quick recap of this explainer. 1, always read a Flutter UI from the outside in. 2, remember your outer widgets control the layout and safety. 3, your inner widgets are where the actual content and interaction live. 4, MVVM strictly separates our view display from our business logic. And 5, the state, whether it's local or in a view model, completely dictates what the UI looks like.
So, I want to leave you with a final thought. Tomorrow, you're going to open up our massive code base and look at a brand new screen you have never seen before. Instead of panicking at the nested code, just ask yourself, which widget will you look at first and why? If you answered the outermost widget to understand the frame, well, you are already thinking like a senior dev. Thank you all so much for your focus today. Go grab some coffee, and I cannot wait to see what you build.